The acronym BARIN stands for Branch and Reduce Optimization Navigator. From this acronym, it is evident that we consider BARIN's range reduction techniques to be vital for its efficiency. In this short video, we will consider the impact of BARIN's range reduction techniques on a standard test problem from literature. For this demo, I'm using the Python interface to BARIN, available through the Python PyOmo package. BARIN is also available through interfaces with Julia in JMP, GAMPS, AIMS, AMPL, MATLAB, and YALMIP. The problem we are considering is the BRY-BND problem from the constrained and unconstrained test problem set, also known as the CUTE set. The problem is seeking a solution to a system of nonlinear equations considered in the least squares sense. Since we don't know where the solution of this system of equations might lie, all variables are unbounded. That is, the ranges or lower or upper bounds are unspecified for every variable. The objective is minimizing the sum of squares of violations of each of the nonlinear equations. There are no additional constraints. Thus, if we find a valid solution to the system of nonlinear equations, our optimal objective will be 0. A non-zero objective will indicate that we are unable to find a valid solution to the system of equations. The lack of valid bounds is a challenge for any global optimization algorithm. As some of the audience members might be aware, branch and bound type algorithms proceed by breaking down the original domain of the problem into smaller subdomains and solving these subproblems recursively. The solution of all of these subproblems provides a globally optimal solution along with a certificate of optimality. Clearly, a larger or an unbounded domain implies that we have more of these subproblems to solve. Furthermore, the methods utilized to solve these subproblems depend on the size of the domain. The quality of the convex relaxations that are employed to find valid bounds for the subproblems are a function of the size of the domain. A larger domain causes the quality of the convex relaxations to decrease. In the context of the BRY-BND problem, it is obvious then that the lack of any valid bounds, resulting in an infinite domain for all variables, would pose a challenge to global optimization. Let's see how BARIN does in solving this problem with PyOmo. BARIN is able to solve the problem in a couple of seconds on my computer. The optimal objective is 0 for all practical purposes. This tells us that we found a solution to the system of nonlinear equations we were trying to solve as an optimization problem. How does BARIN do this? The secret is in the range reduction techniques that have been implemented in BARIN. Before I continue, I'm going to initiate a quick run since that's going to take a while to solve. BARIN employs several techniques to infer valid ranges for each of the variables in a problem that are tighter than the user-specified ranges. These are broadly classified into two: feasibility-based bound tightening techniques and optimality-based bound tightening techniques. Feasibility-based bound tightening techniques utilize feasibility-based arguments. By analyzing the nonlinear functional forms in the problem and by analyzing the problem constraints, they infer valid bounds on variables outside which no feasible solution is guaranteed to lie. Optimality-based bound tightening techniques infer valid bounds through optimality-based arguments. By proving that no globally optimal solution can lie outside certain bounds on the variables, these techniques are able to tighten variable bounds. Their impact is visible by running the same problem again by turning these techniques off. By setting the LB, TTDO, OB, TTDO, TDO, MDO, and PDO options to 0 in BARIN, I have turned off all the range reduction techniques in Baron. Baron is still able to find the globally optimal solution, but takes considerably longer for the process, about a couple of minutes. This demonstrates the importance of range reduction techniques for global optimization in general and Baron in particular.